Welcome, this is Larry Benko W0QE, and whether you are new to this channel or have been here since the beginning, this video should be valuable, as I consider plotting to be one of the best ways to understand any circuit. Most of the new features in SimSmith get added, used by us, and modified before becoming mature, and plotting is a good example of why I am revisiting this topic. Shown in this slide is a very crude history of SimSmith from my point of view. It may not be exactly correct chronologically, but it's close. From the very beginning up through version 16.6. And the first thing was SimSmith was created with the idea of always operating in real time. We kind of take that for granted right now, but if you go back and use a program like LT-Spice, you can see the difference between SimSmith and LT-Spice. If you're trying to adjust components or things like that, you have to keep stopping and rerunning it again, and it's not dynamic in that regard at all. Second thing is plotting, and by plotting I include the built-in plotting features that SimSmith has, but also all the specialized pieces that you can customize to exactly what you want to plot. You can plot anything you want. You could plot the ratio of a capacitance to some voltage across a component if you wished, and that's perfectly fine. A little before plotting, the end block was created, and later the Ruse block, which is nothing more than a front end on top of the end block. And this allowed us to have circuits that could be very complex and be able to be fairly easily created by the user. Prior to this time, the F block existed, and the F block still exists in SimSmith, but in my opinion, the F block is extremely hard to write the equations for if the circuit's complicated. Some of the videos I've done where there were transformers and baluns and stuff in the video, I'd be hard pressed to write the equations for that in an F block. Yet in a Ruse block, it's extremely simple. I used to use the N block. Now that the Ruse block has become stable, the Ruse block is what I use almost exclusively. And finally, the programming language Anvil, which allows you to pretty much do anything you want to in SimSmith. I have not done any videos including this yet. I intend to do some, but this is a pretty advanced feature. But along the way, things like component sweeping and file-based components such as an antenna where the impedance is not 50 ohms at all frequencies. Component voltages and currents were displayed on the block for each of the components. These were all incremental add-on features that made SimSmith more and more valuable. The ability for the mouse to control so much of SimSmith. It's almost impossible to use SimSmith without a mouse, in my opinion. And finally, Harmonics, which is the ability to have more than one frequency present at a given time, which is useful for analyzing the size of components needed in filters and diplexers, triplexers, etc. And again, while it may not be a real common feature, I've done a couple videos on it, and it does have a use. With these four primary features, you can analyze a huge group of circuits that you couldn't do in a normal Smith chart program that SimSmith can do just fine. Now let's look at plotting in a little more detail, since plotting has really stabilized in version 16. Let's start with a simple circuit containing four components. We have a generator, which is an absolute voltage generator, so there's no series resistance. It's a perfect voltage source, 10 volts RMS, followed by a Ruse block, which contains nothing more than a capacitor in it, whose value is specified right here, which will be 50 ohms of reactance at 10 megahertz, a 5 ohm resistor, and a 45 ohm load. And if we look at what SimSmith gives us by default in the way of plotting, we see a couple things. We see these values right here, and they're a voltage and a current, and they have some arrows. And the arrows try to tell us which way the voltages and currents are measured. In the case of this resistor, which is in series, we see the lines go, the arrows going left and right, telling us that voltage 0.7 volts is across the resistor and 0.14 amps is through the resistor. And SimSmith tries its best to get this correct, although sometimes you want something different than what SimSmith gives you. Nevertheless, it's very useful. It's only valid at the frequency of the generator right here. As we can see, as we change the generator, these values change, of course. And that was the first part of plotting. In addition to the basics, the basic plotting has been SimSmith for a long time. In the Smith chart, we have the SWR looking this direction at the generator, at the A block, the R1 block, the load, and we can plot those. We see at the load it's 45 ohms. We see at R1, of course, it's 50 ohms looking to the left. And the generator is this sweep pattern right here. Also, we can plot both a path with the ruse block, of course, being not an arc anymore because the ruse block doesn't know that that's a capacitor. Just an impedance starting and impedance ending, because this could contain many different components. So we have a path, we have a sweep versus frequency, which is 1 to 100 megahertz, and we have both. And we also have the square chart. The square chart is interesting in that it has four axes, has an extra axis over here and an extra axis over here that aren't shown right now, and they're not unavailable to the user without doing a little bit of programming. But it does provide a power axis on the left, which is controlled right here with whatever we choose to plot, and an SWR axis on the right, and again, we're choosing based on what we choose to plot. The SWR axis shows a solid line under it, solid line in the graph. The power axis shows a dashed line in the graph. The power axis is showing watts to the left, which means that's the power delivered into each of these blocks. And we see it starts off at 1 watt in this case. 1 watt and 0.9 watts makes it to the load. Now, if we change the ordering of that, we see 9/10 of a watt is dissipated in the load, 1/10 of a watt is dissipated in the resistor, and nothing is dissipated. Well, 1 microwatt is dissipated in the capacitor here, and that's based on the Q being 1 million. Since I didn't specify a Q for it, SimSmith picks 1 million as the Q, and that's pretty much what SimSmith gives us for plotting. And while it's adequate for a lot of things, there are a lot of times you want a little bit more. You may want to know a voltage from here to ground. I can't get that. Sure, I could put a resistor in there. I could make it a large value resistor, say like 1 gig ohm, and I could read the voltage. In that case, it's the voltage across here. We see 7.07 volts. We could have added these two up since they are in phase, but you used to have to play some of those games. Now SimSmith gives us the ability to plot a lot of that stuff directly. And let's look at that plotting. I have a plot window in the G block here, and this is where plotting initially started, and it has now moved into other places too. You can plot from within ruse blocks and other places, but we'll get to that in a few minutes. Basically, we have the built-in stuff we talked about. Oh, I didn't mention the fact that all these plots can be, the color can be changed. You right-click on the tab here, you pick a new color. Let's pick, say, yellow for this plot. So this one, the R1 now becomes yellow plot. The plotting that SimSmith has come up with has a bunch of commands. The most basic command is the plot command. Plot something. That's all you need to do. SimSmith will fill in all the blanks for you after that. May not be what you want. If you want a little more control, then you have to take control away from SimSmith. Wave. Wave gives you a waveform you can plot. RMS gives you the RMS value of something. Peak gives you the peak value of something. Peak is useful mostly with harmonics because if you know RMS, peak is just the square root of 2 times it for a single frequency. Power, and power is interesting because power something gives you the total power, including harmonics, but plot something and put it on the power axis gives you the fundamental only, because sometimes you want to separate the two of those. You can do Smith, plot something on the Smith chart, which is the same as plot something on the Smith chart, and SWR something is plot something on the SWR axis. Again, 5 possible axes. We have the Smith chart as 1 and the 4 axes on the square chart. And they're labeled power. Y1's on the left side, Y2's on the right side. You can rename those. What can you plot? Well, you can plot a lot of stuff. And let's move this away for a minute. We could plot L.V. This is ugly being yellow here. Let's change its color again to something, say like purple. So what can you plot? L.V. If we plot L.V here, that's the voltage across here. We can plot R1.p, that's the power consumed by the resistor. A.R2.V. Well, R2 doesn't exist, but it's in block A. We go in there and look, and there would be an R2 in here if this was going to work. And we would look at the voltage, since it's a small v, we look at the voltage across it. C2.Zn. If we had a C2, let's put one in real quickly. C2.Zn is the impedance on this side of block C2. And that's the same as A.Z, but this should have been C2, sorry. But C2.Zn is still the right side of this block, and it's not equal to A.Z now. Here it is equal to, and the other time it's not. So there's times when you want to know it's on the right side of a block. Zn is what you get there, what you use for that. We can plot L.invZ, inverse Z. That is what impedance right here at the L boundary will give us a match at the generator. We can do the reverse Z, which is just start here and look this direction. What impedance do we see? You can do any math you want. It can be a constant number. All those are legitimate things to plot, and they're all useful at certain times and in certain places. And where can we plot from? We can plot from just about anywhere. If we have a D block, and a D block is the only block that can be to the left of the generator, we can plot within the D block, put plot commands in there. We can plot in the ruse block. There is one plot command in here already, which has been commented out. We can plot in an F block. We can also plot in the generator block, of course, which was the original place where plotting began. And while this sounds really complicated, let's look at this from some examples. Before I get going with the examples, the reason none of the examples show is because /* followed by */ means everything in the middle here is to be ignored. Again, all the text up here, SimSmith would give us lots of errors with this text, but if I comment it all out, it's gone. This one line, // comments that one line out. So let's go down here and remove the comments around all these plotting commands. And we see an error when we delete when we delete this because it's imbalanced. We delete the other side, now we're back to being error-free. So look at all the things we can plot. Let's turn off the two main plots to begin with, and let's just click on these one at a time. We can plot the magnitude of R1.V. Now, plotting the magnitude of R1.V means the voltage from here to ground, since it's capital V, and we have to do magnitude because at this point, this is a complex number. If we did not do magnitude and we did just R1.V, we see that the argument is not purely real. And on this plot right here, there's no place to plot an imaginary number. You can only plot numbers that are scalar. And it could be an imaginary number, but it's just the number you're plotting. So if we go back here and fix this for the moment, we're back to everything being okay again. So if I have to type magnitude in here, there's another command called RMS. RMS is useful primarily when we have harmonics and stuff, but it's also useful for voltage and current because the voltage and current will not be purely real, and then you get the error all the time. You have to put magnitude in front of it. So we have the command RMS, which gives us the same answer. So if we plot RMS, and each one of these colors is going to overwrite the previous one. So this one, which was the magnitude of R1.V, here's RMS of R1.V. It's exactly the same plot. Now, the next plot, color. What have we done? We specified the color here. We could have gone here, right-clicked on it, picked a new color, but we're specifying it here. That is useful in case you want to make these parameters and change the color of a line partway through the sweep. That's doable. And in this case, we also named the command. The specs for plot look like this, and if you do them in this order, you're safe. And I've got it under good authority that what I'm doing here is the way that SimSmith is going to work looking forward. So the first thing we specify, if we wish, they're all optional. The only thing that's not optional is the what. You got to pick something to plot. The pen specs. Do them in a certain order, you'll be fine. But there's three things you can do. You can do a stroke on the width with lots of stuff going on we'll get to. You can pick the color. All those things go right here. So it would be color would be first, stroke would be second, and third would be the stamp or whatever you want to think of these things as, like stars or dots or triangles. Those would all go in here. Name's optional. If you don't use name, SimSmith picks a name for you. In this case, right here, the first one, magnitude R1.V, we didn't give SimSmith a name to use. It used what we actually put in for the math. And that was perfectly fine. Next thing we plot is the what. You got to have that one. Axis name, if you want to rename the axis, that's fine. Or name the axis. And then axis is what you want to pick. If you don't pick an axis and you plot, in the plot command, it goes to the Y1 axis. RMS goes to the Y1 axis. If you use the command Smith, of course, the default goes to the Smith chart. And again, you kind of have to play around a little bit, but it's really pretty intuitive after a while. So let's just continue. So now we picked a color here. Here's the same plot again. What have we done? We've picked the stroke width. We didn't pick a color, so we took the default color SimSmith gave us. We made it 4 dots wide. That makes this one particular plot stand out versus something else. So if you had plotted SWR over here and you wanted this one to be wider, it still shows that as a dotted line, but we've overridden that. We've made this now be a wide line. Now, how about a dashed line? Again, stroke 6. 6 is the width, 6 dots of on, 10 dots of off. So it's less than, it's a sparse line. We could have made it, there, it's more solid now. So you can pick what you want. And again, I named it wide dash. If I don't rename these, they'll all end up having the same name. And several things with the same name, SimSmith only gives you the last one. All the rest of them don't count. So you have to give them new names. The next thing we could have, stars. Now, these stars may not be very visible. We can make them bigger, but for right now, they're stars. And the number of stars that we get is the number of points that we plot here. If we want fewer stars to appear, we plot fewer points. I don't use the stars very often. I like the lines with the dashes and different thicknesses much better. But you can plot stars, triangles, diamonds, squares, and a thing called sevens, which are 7-pointed stars. And they all plot. Let's continue on. We're going to plot large triangles. So what are we doing? We're stroke 5. 5 sets also works on the size of these things. And we get triangles. While we're talking about that, there's a command here in the preferences. Let's just close this off. In the preferences called circle size factor. It affects the circles like here and here and that circle. It also affects the size of these. So since it affects both of them, I set it for the circles that I want, and then I use the stroke command to adjust the size of the, in this case, the triangles. Okay, back to the plot. Now, let's do the next one. This is the works. We've picked a color. Again, all this is documented in the manual. The colors, and put the color first. The stroke is 858. Since dots are chosen, the 5 and the 8 don't have any effect. SimSmith just uses the width. 5 and 8 only applies to lines. We can get rid of those. And we see circles. 101 of them again, since there's 101 points. We've named it all. We plot, again, R1.V. We haven't done anything with the axis. So again, we get Y. We get Y1. Down below here, though, we're going to plot something different. First thing we're going to plot is G.V, and we're going to plot G.V with a stroke width, and it's dashed line, and it's going to be put on the Y2 axis, and we're going to name the Y2 axis V. So here's the Y2 axis. We named it V. Let's say if we want to call it, say, volt, we can see that it changed to volt up here. You're limited in size, so don't, if you become too verbose, then obviously what you get here is so small you can't read it. This axis now can be moved. when you're looking at a waveform, it's nice to put 0 in the middle a lot of times. And we have chosen a stroke width of 4 with 8 dots of line and 3 dots of gap between the lines. We're also going to plot now C.V and R1.V. R1.V, of course, being this voltage from here to here, which is the voltage across the resistors. C1 dot small v is the voltage across the capacitor. This has 50 ohms reactance. This is 50 ohms of resistance. The two voltages are equal. This voltage here is the sum of those two voltages, considering the phases. So if you're learning about AC electronics, SimSmith can show you the waveforms very nicely. I mentioned previously that you could plot in several places, such as the generator, which was the default original place, within a RUS block, within an N block, in the D block. And while you can do all those things, it doesn't make sense to just plot everywhere. I generally plot within the G block mostly, just because that's the way it's always been done. And then if I have a RUS block that I want to save and bring back into a circuit or bring into other circuits that has plotting associated with that particular circuit in the RUS block, I'll do that plotting within that RUS block itself. That way, if I save the component and I bring it back, the plotting stays with that block. Occasionally, I'll plot in the D block if the D block's to the left of the load, but that's pretty much what I do. It's kind of personal preference, but if you plot a lot of different places, you can end up with things being pretty messy. SimSmith doesn't seem to care as long as you don't have ambiguities with what you're naming the plots to be, and it all works. But a little bit of common sense in this area can go a long ways. That's all I had planned for the plotting. One thing we can do very quickly, though, is we can come back and look at harmonics real quickly. I did a video on harmonics in the past, but now we see the waveforms show the harmonics, and they show exactly what you have. The voltage, we see the voltage, the generator voltage, we see it looking as you would expect to for a fundamental frequency where the harmonic is in phase with it, the third harmonic. Let's make the third harmonic out of phase with it. We see this waveform. You can do anything you want in SimSmith. I mean, the power is pretty cool here. But now when we look at the capacitor voltage, we see it looking like this. This is the voltage on the capacitor. Here's the voltage on the resistor. Again, they both add up to be the red trace. Again, very powerful. We can plot the power in the third harmonic at the load if we wanted to. We would do that with the power command, and we'd get both of them. We could use plot power, as I showed. Plot power is the fundamental only, and power is both. And this command down here is the power just. Let's just do that one. That one shows the power, and if I change the harmonics to go away by commenting this outer, we see that the power is still the same in the load as we had just a moment ago. Anyways, this is all I had planned for plotting, but there's a huge amount of power here, and I can't impress upon you enough that it's important to learn how to plot some of these things. You don't have to be a plotting master, but you can really do a lot that will help your understanding of a circuit. And again, when it's all done, the only thing that really is important is to understand what's going on. Hope you've enjoyed the video. If you like these kind of videos, let me know. If you got some suggestions for different videos, let me know about that also. And again, there'll be another video.